Hello, everybody. Welcome. We are going to be talking about another type of transformation today. We are going to be talking about reflections. When you think about reflections, I want you to think about a shape getting flipped over a line. So think about a reflection as a flip. A figure is flipped over a line, and usually we call that line a line of reflection. There are a couple of rules, coordinate plane rules for reflections. One is when you reflect across the x-axis or over the x-axis, it's where xy becomes x comma negative y. Now this doesn't mean that the y becomes negative if it's already negative. So you just change the sign. So in this case, we keep the x and we change the sign on the y. Okay, let's go ahead and try that out on example number 1 over here. So we're going to keep the x. I'm going to go ahead and write all my x values here, -3, 5, -4. And then we're going to change all of the y values here. So the 4 becomes a -4. The 0 stays 0. 0 doesn't actually change. And the positive 1 becomes a -1. And then this is the original triangle already plotted. Let's go ahead and plot the point for our new image. So this was the original, and this is the new. Okay. Done. Now we're going to look at the other rule that we've got here. This other rule is a reflection over the y-axis. When you have a reflection over the y-axis, that's this one here, you change the x and keep the y. Okay, so we're going to practice that on this example here. I've already got my, so before we called it an original and a new, there's another way that you might see it referred to as the pre-image and the image. So, but it's the same concept as original and new. All right, so this time we're changing our x's. So instead of -6, I have +6. Instead of +2, I have -2. Instead of -2, I have +2. And then all the y's stay the same, 2, 4, -1. I'm going to go ahead and plot those and see what we come out with. Now I want you to notice between the pre-image and the image, the shape didn't change. Didn't change here either. The distance between the points didn't change at all. All of the angles stayed the same, and all of the sides stayed the same length. So the pre-image and the image are congruent. The corresponding angles are congruent. And the corresponding sides are also congruent. So when everything stays the same size and the same shape, we have something called isometry. So you can say that a reflection is a type of isometry. There are 2 practice problems right here. Please do them on your own. Pause the video because I'll be putting up the answers next. We're on the back of the notes now, and we're thinking about the question, what if we wanted to reflect across a line other than the x or the y-axis? Let's say we wanted to reflect across the line x = 1 or y = -2. Those are both reasonable things to want to reflect across. But there's not a rule like there is for reflecting across the x-axis or reflecting across the y-axis. All that you do is count to the line of reflection and then count that same number away from the line of reflection. Let me show you what I mean. So this line right here is x = 1. It's a vertical line. And so I'm going to start at point A and I'm going to count the spaces to the line. I count 2 spaces to that line of reflection. Then I count 2 spaces away, and that is where my A prime is going to be. I'm going to do the same thing with B. I'm going to count 1, 2, 3, 4 spaces to the line of reflection, and then 1, 2, 3, 4 spaces away from the line of reflection, and that's my B prime. Same thing here with C. 1, 2, 3, 4, 5, 6 to the line of reflection, and then 1, 2, 3, 4, 5, 6 to my C prime. I'm going to connect those dots and fill in those points. I'll be right back. Am I not reflecting? Oh, that's awesome. Happy Christmas. The same concept works when you are reflecting across y equals -2. You count to the line and then away from the line the same amount. 1, 2, 3, 1, 2, 3. There is C prime. 1, 2, 3. 1, 2, 3. There is B prime. Now, A actually ends up going off of the grid just one little point. 1, 2, 3, 4, 5, 6, 7. And remember not to stop at the axis, stop at the line of reflection. 1, 2, 3, 4, 5, 6, 7. So this is where A prime is. And let's fill in those points. -1, -9, 2, -5, and -5, -5 for C. There are 2 other reflection scenarios I want you to know about. One is reflecting across the line y equals x. And the rule for that is AB becomes BA. Essentially what happens here is that you switch the A and the B. So working with the points first here, they don't change signs, they just switch positions. So this becomes -5, 2, this becomes -1, 4, and this becomes -7, 6. Then you can plot those points and you should see this shape reflected on the other side of that line. And there's our new shape. Let's try this again, but this time let's try it with reflecting across the line y equals -x. Now notice this time my line of reflection has a negative slope. And the rule this time is AB becomes -B, -A. So we're actually going to do 2 things here. We are going to switch just like we did before, and we are going to change the sign. Let's try this a couple of times. So -3, -1 become +1, +3. 0, -5 becomes +5 and 0. Remember, 0 doesn't change signs. And then -7, -5 becomes +5, +7. Let's go ahead and plot those points. All right, this is our pre-image. This is our image reflected across the line, y equals -x. You do have some practice problems to work on today. Hopefully this was understandable for you. Have a great day. Remember to ask if you have questions.